The National Electrical Code, NEC, mandates a minimum separation distance between electrical runs and water lines. This requirement is detailed within NEC section 300.20b. Specifically, the NEC stipulates a minimum distance of 18 inches between electrical runs and water lines. To properly measure this distance, one must consider the outermost surface of the electrical conduit or cable and the nearest surface of the water line. The measurement is taken from the closest point on the electrical conduit or cable to the closest point on the water line. In situations where the electrical run is concealed within a wall or ceiling, the measurement methodology changes slightly. In these cases, the distance should be measured from the outside surface of the wall or ceiling to the nearest surface of the water line. This ensures that the required clearance is maintained even when the electrical and water lines are not directly visible. If the electrical run is buried underground, a different measurement approach is necessary. For underground installations, the distance is measured between the top of the electrical conduit or cable and the top of the water line. This vertical separation is crucial for preventing potential hazards. There are additional considerations to keep in mind. In certain cases, such as when the water line is under pressure, additional clearance beyond the standard 18 inches may be necessary. This precaution is taken to minimize the risk of electrical faults in the event of a water line rupture or leak. It is always advisable to consult the local building code or a qualified electrician for specific guidance on clearance requirements in such situations. Local building codes may have more stringent requirements than the NEC, and a qualified electrician can provide expert advice tailored to the specific installation conditions. The NEC is a comprehensive set of standards that governs electrical installations in the United States. It is updated every 3 years to reflect the latest advancements in electrical technology and safety practices. The purpose of the NEC is to safeguard persons and property from hazards arising from the use of electricity. Compliance with the NEC is essential for ensuring the safe and reliable operation of electrical systems. Section 300 of the NEC covers general requirements for wiring methods and materials. This section includes provisions for the installation of electrical conductors, cables, and raceways. It addresses issues such as physical protection, support, and grounding. Section 300.20 specifically addresses the installation of conductors with respect to induced heating. This section is concerned with minimizing the risk of overheating in metallic enclosures or raceways due to induced currents. The requirement for a minimum distance between electrical runs and water lines is found in subsection 300.20b. This subsection is intended to prevent the water line from acting as a heat sink, which could reduce the ampacity of the electrical conductors. Ampacity refers to the current carrying capacity of an electrical conductor. The ampacity of a conductor is determined by its size, insulation type, and installation conditions. When conductors are installed in close proximity to water lines, the water line can absorb heat from the conductors, reducing their ampacity. This can lead to overheating and potentially create a fire hazard. By maintaining a minimum distance of 18 inches between electrical runs and water lines, the risk of this occurring is significantly reduced. It's important to understand the principles behind these code requirements. The NEC isn't just a set of arbitrary rules, it's based on sound engineering principles and years of experience in electrical safety. Understanding the rationale behind the rules can help electricians and other professionals make informed decisions and ensure the safety of their installations. The NEC is not a design manual. It provides minimum requirements for electrical installations, but it does not provide detailed design guidance. Electrical engineers and designers are responsible for developing electrical designs that meet the specific needs of a project while also complying with the NEC. The NEC is enforced by local electrical inspectors. These inspectors review electrical plans and inspect electrical installations to ensure that they comply with the code. It is important to work closely with local electrical inspectors to ensure that your electrical installations are safe and compliant. Failure to comply with the NEC can result in fines, project delays, and even legal action. The NEC is a living document that is constantly evolving to meet the changing needs of the electrical industry. It is important to stay up to date on the latest changes to the code to ensure that your electrical installations are safe and compliant. There are many resources available to help you learn more about the NEC. These resources include books, online courses, and seminars. You can also consult with a qualified electrician or electrical engineer for assistance. Remember, electrical safety is everyone's responsibility. By following the NEC and other safety guidelines, you can help to prevent electrical accidents and protect yourself and others from harm. The NEC is a crucial resource for anyone involved in electrical work. It provides the guidelines and standards necessary to ensure safe and reliable electrical installations. Understanding and adhering to the NEC is essential for protecting people and property from the hazards of electricity. Let's delve into some more specific scenarios and considerations related to the distance between electrical runs and water lines. Consider a situation where you have multiple electrical conduits running parallel to a water line. In this case, the 18-inch clearance should be maintained between the water line and the closest conduit. The presence of multiple conduits does not change the basic requirement. Now let's consider a situation where the water line is not a straight run but has bends or curves. In this case, the 18-inch clearance should be maintained at all points along the water line. You may need to adjust the routing of the electrical runs to ensure that this clearance is consistently maintained. Another important consideration is the type of materials used for the electrical conduit and the water line. For example, if the water line is made of a conductive material such as copper, the risk of electrical shock is higher than if it is made of a non-conductive material such as PVC. In this case, it may be necessary to increase the clearance beyond the minimum 18 inches. Similarly, the type of insulation used on the electrical conductors can also affect the required clearance. Conductors with high temperature ratings may require less clearance than conductors with lower temperature ratings. This is because conductors with higher temperature ratings are less likely to overheat and pose a fire hazard. The NEC provides tables that specify the allowable ampacity of conductors based on their size, insulation type, and installation conditions. These tables should be consulted when determining the appropriate clearance between electrical runs and water lines. In addition to the NEC, local building codes may also have requirements for the distance between electrical runs and water lines. These local codes may be more stringent than the NEC, so it is important to check with your local building department to ensure that you are in compliance. When in doubt, it is always best to err on the side of caution and increase the clearance between electrical runs and water lines. This will help to minimize the risk of electrical shock and fire. It is also important to ensure that all electrical work is performed by a qualified electrician. A qualified electrician has the knowledge and experience necessary to install electrical systems safely and in accordance with the NEC and local building codes. Attempting to perform electrical work yourself without the proper training and experience can be dangerous and can result in serious injury or even death. In addition to maintaining the proper distance between electrical runs and water lines, it is also important to ensure that all electrical equipment is properly grounded. Grounding provides a path for fault current to flow back to the source, which helps to protect people from electrical shock. The NEC specifies the requirements for grounding electrical systems. These requirements include the use of grounding electrodes, grounding conductors, and bonding jumpers. Proper grounding is essential for electrical safety. Another important safety consideration is the use of ground fault circuit interrupters, or GFCIs. GFCIs are devices that detect small amounts of leakage current and interrupt the circuit, preventing electrical shock. GFCIs are required in certain locations such as bathrooms, kitchens, and outdoor areas. They are an important safety feature that can help to protect people from electrical shock. Regular inspections of electrical systems are also important for maintaining safety. Electrical systems should be inspected periodically by a qualified electrician to identify any potential problems. These inspections can help to prevent electrical fires and other hazards. It is also important to be aware of the signs of electrical problems. These signs include flickering lights, sparking outlets, and unusual odors. If you notice any of these signs, you should contact a qualified electrician immediately. Electrical safety is a shared responsibility. By following the NEC local building codes and other safety guidelines, we can all help to prevent electrical accidents and protect ourselves and others from harm. Let's further examine the specific language and intent behind NEC section 300.20. B. The key phrase is induced currents. When electrical conductors carry current, they generate electromagnetic fields. These electromagnetic fields can induce currents in nearby metallic objects such as water lines. If these induced currents are allowed to circulate, they can cause the metallic object to heat up. This heating can reduce the ampacity of the electrical conductors and potentially create a fire hazard. By maintaining a minimum distance between electrical runs and water lines, we can reduce the strength of the electromagnetic fields and minimize the induced currents. The 18-inch clearance specified in NEC section 300.20 E is based on empirical data and engineering calculations. It represents a reasonable balance between safety and practicality. While a larger clearance would provide even greater safety, it may not always be feasible in real-world installations. The NEC aims to provide practical and enforceable rules that can be applied in a wide range of situations. It is important to note that the 18-inch clearance is a minimum requirement. In some cases, it may be necessary to increase the clearance to address specific conditions. For example, if the electrical conductors are carrying a very high current, the electromagnetic fields will be stronger and a larger clearance may be required. Similarly, if the water line is made of a highly conductive material, the induced currents will be greater and a larger clearance may be needed. The NEC does not provide specific guidance on how to determine the appropriate clearance in these situations. It is up to the qualified electrician or electrical engineer to use their professional judgment and experience to assess the risks and make appropriate recommendations. In addition to the distance between electrical runs and water lines, the NEC also addresses the bonding and grounding of metallic water piping systems. Bonding is the process of connecting metallic objects together to create a low impedance path for fault current to flow back to the source. Grounding is the process of connecting the bonded system to the earth. Proper bonding and grounding of water piping systems is essential for preventing electrical shock. If a fault occurs in an electrical system, the fault current can flow through the water piping system and energize it. If the piping system is not properly bonded and grounded, anyone who comes into contact with it could receive a dangerous electrical shock. The NEC specifies the requirements for bonding and grounding water piping systems. These requirements include the use of bonding jumpers, grounding electrodes, and ground fault circuit interrupters, or GFCIs. It is important to follow these requirements carefully to ensure the safety of people and property. Let's explore some additional scenarios. Imagine a situation where you are installing electrical conduit in a crawl space. Crawl spaces are often damp and confined, which can increase the risk of electrical shock. In this case, it is especially important to maintain the proper clearance between electrical runs and water lines. You may also want to consider using corrosion-resistant conduit and fittings to protect the electrical system from moisture. Now, consider a situation where you are installing electrical wiring in a commercial building. Commercial buildings often have complex electrical systems and a large number of electrical devices. In this case, it is essential to have a well-designed electrical system that complies with the NEC and local building codes. You should also consider using surge protection devices to protect sensitive electronic equipment from voltage spikes. Another important consideration is the labeling of electrical panels and circuits. Electrical panels should be clearly labeled to identify the circuits that they serve. This will help to make it easier to troubleshoot electrical problems and to safely disconnect power to specific areas. The NEC provides requirements for the labeling of electrical panels and circuits. These requirements should be followed carefully to ensure the safety of people and property. Finally, it is important to remember that electrical safety is an ongoing process. Electrical systems should be inspected and maintained regularly to ensure that they are operating safely. If you notice any problems with your electrical system, you should contact a qualified electrician immediately. By taking these precautions, you can help to prevent electrical accidents and protect yourself and others from harm.